Greetings. My name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 2 on derivatives and segment 2.3 on the power rule. Instead of using the definition to find the derivative, the process can be streamlined using the basic power rule. If f of x is equal to x to a power, then the derivative f prime of x equals n times x to the n minus 1 power. For example, if we had x to the 6th power, the derivative f prime of x would be 6x raised to 1 less power, the 5th power. If y is equal to 1 over x squared, first we would rewrite the problem as x to the negative 2 power. Then the derivative would be negative 2 x raised to 1 less power, which would be negative 3. Rewriting this, I would have negative 2 divided by x to the 3rd power. If y is equal to the square root of x, we would begin by rewriting the square root of x as x to the 1/2 power. Then dy dx, the derivative, would be 1/2 x to the minus 1/2 power. I would rewrite this problem without a negative exponent as 1 over 2 square root x. I move the x to the minus 1/2 to the denominator and put it back in a radical format. Another example. Suppose that we had a coefficient in front of the function, as in 4x to the 5th. Then the derivative would be, we bring the 5 around and we multiply by 4, 20x to the 4th power. If y is equal to 8, then dy dx, the derivative, is 0. If f of x is equal to 2x to the 5th minus 4x cubed plus 2x divided by x to the 3rd, we would have to begin this problem by dividing 2x to the 5th by x to the 3rd would be 2x to the 2nd, minus 4x to the 3rd divided by x to the 3rd would be minus 4, and 2x divided by x to the negative 3 would be plus 2 x to the negative 2. Now we find the derivative, f prime of x, using the basic power rule, so that the derivative would be 4x. Remember, the derivative of a constant is 0, and the derivative of 2x to the negative 2 would be minus 4x to the negative 3. Rewriting this expression without the negative exponent, we would have 4x minus 4 over x to the 3rd. If you want to rewrite this answer as a single fraction, then we would keep the denominator x to the 3rd, and this first term would convert to 4x to the 4th power, and then we still have our minus 4. So the derivative would be the quantity 4x to the 4th minus 4 divided by x cubed. Please note that the derivative gives us an instantaneous rate of change of a function at a given x value. Let's look at this problem. The ticket sales for the 8 days preceding a concert is given by this function, where x is the number of days before the concert. The first question, what is the actual number of tickets sold 6 days before the concert? To find the answer to this, we would simply plug 6 into the original function. 5 times 6 squared plus 40 times 6 plus 6,000. We can do this on our calculator. To begin, we would have to enter the function under y equal. Then we could go to the vars key, scoot over to y variable, select number 1 function, and then select where your function is stored. Since my function is stored under y sub 1, I will select number 1. And then in parentheses, substitute or enter the number that you want to substitute into this function, which in this case was 6. So I obtained 6,420. So that means that 6 days before the concert, 6,420 tickets were sold. Now let's go to our second question. What is the instantaneous rate of change in sales 6 days before the concert? To answer this question, we need to use the derivative of the function. So the derivative of this function, s prime of x, would be, we bring the 2 around and multiply by 5, that would be 10x plus 40. And we would substitute 6 into the derivative. S prime of 6 would be 10 times 6 plus 40, which is equal to 100. Let me show you how you can do this on the calculator. Recall that we have our function still stored under y sub 1. What I want to do is go to the math key, and I'm going to select function number 8, which is nth derivative. I have to enter 3 things. First, I have to enter the original function. Well, since I have it stored as y sub 1, I'm just going to put in y sub 1, followed by a comma. The second thing that you have to enter is the variable x, followed by a comma, and then the number that you want to plug into the derivative. In this case, it's the number 6. Close the parentheses, press enter, and you obtain the 100. So in conclusion, 6 days before the concert, sales are increasing at a rate of 100 tickets per day. The actual sales were 6,420. Those sales are increasing at this rate. Well, that's it for this segment. Now you need to practice this concept by working similar problems. Good luck.